Hi, this video is here to help you with recognising and describing 3D shapes. Let's remind ourselves of some of the vocabulary relating to shapes before we begin. A 2D shape has two dimensions, length and width. 2D shapes are flat. A 3D shape has three dimensions, length, height and width. 3D shapes are solid. These are also known as polyhedrons, a 3D shape whose faces are all polygons. Let's have a go at identifying and naming some 3D shapes. Can you name the shape as it appears on the screen? It's a cube, a cuboid, a square-based pyramid, a tetrahedron, which sometimes gets called a triangular-based pyramid, a triangular prism, a pentagonal prism, a hexagonal prism, an octagonal prism, and an octahedron. How many of the shapes could you name? Now that we've recognised and named the shapes, let's have a look at how we can describe them. When we're describing 3D shapes, we can identify their properties. We can say how many edges, how many vertices, and how many faces a shape has, and what 2D shape the faces are. Vertex is the singular form and vertices is the plural form, so you may see both forms being used. A face is one of the 2D plane surfaces of a 3D shape. Faces are flat. This cuboid has 6 rectangular faces. An edge is the intersection of two faces, the straight line where two flat faces of a polyhedron, the 3D shape, meet. This triangular prism has 9 edges. A vertex is a point where 3 or more edges meet on a 3D shape. This square-based pyramid has 5 vertices. Let's use this vocabulary to describe a 3D shape. This is a triangular prism. Let's start by counting the faces. A prism has 2 opposite identical faces. In this case, 2 opposite triangular faces. So we can start by counting these and then count the other faces. 1, 2, 3, 4, 5. There are 5 faces, 2 triangular faces and 3 rectangular faces. Next, let's count the edges. We need to remember to count the edges on the opposite ends and between the rectangular faces. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges. Finally, we'll count the vertices. 1, 2, 3, 4, 5, 6. There are 6 vertices. When we can move the 3D shape around like this, we can check that we've counted them all. But if we're using a 2D representation of a 3D shape, we need to be able to imagine the shape in our head to visualise each face, edge and vertex. We can also mark them off to help us. To count the faces on a triangular prism, we'll start with the opposite faces again, beginning with the one that we can see. 1, 2. Next, we'll move on to the rectangular faces, again beginning with the one that we can see. 3, 4, 5. We can repeat this for the edges, again starting with the ones that we can see each time. 1, 2, 3, 4, 5, 6, 7, 8, 9. And finally for the vertices, again starting with the ones we can see. 1, 2, 3, 4, 5, 6. If you're using 2D representations of 3D shapes, jottings on the picture can help you to remember which ones you've already counted and to make sure you count all of the faces, edges and vertices, even if you can't see them in the picture. Now it's your turn. For each of these shapes, name it and then describe how many faces, edges and vertices it has. First row has been done for you. Pause now while you answer the question. How did you get on? Here are the answers. You can pause the video again if you need a little longer to check them. Now it's time for you to use your knowledge to answer a challenge question. Sammy can only see one face of a 3D shape. The face is a square. Sammy says the 3D shape must be a cube. Do you agree with Sammy? Remember to explain your answer by giving examples. Pause now while you answer the question. How did you get on? Because Sammy says it must be a cube, we disagree with her. The 3D shape could be a cube, but it could also be any other 3D shape that has a square face. For example, it could be a cuboid or a square-based pyramid. I hope this video has helped you to recognise and describe 3D shapes. If you're looking for more maths help, then there are lots more videos like this on the Twinkl website, so go and check them out.
This video is here to help you when recognising nets of 3D shapes. Let's take a look at some shape vocabulary before we begin. A 2D shape has 2 dimensions, length and width. A 3D shape has 3 dimensions, length, height and width. 3D shapes are solid. They can also be known as polyhedrons. A polyhedron is a 3D shape whose faces are all polygons. A net is the 2D pattern of a 3D shape. If you unfolded a 3D shape, unfolded the faces so that they lay flat, you would get the net of the 3D shape. When we're thinking about what the net of a 3D shape will look like, we need to think about the faces of the 3D shape, how many there are and what shape they are. If you need a reminder about describing 3D shapes, watch the Recognise and Describe 3D Shapes video. Let's start by having a look at a net and identifying what 3D shape it is for. This net is made up of 5 2D shapes. So we know the 3D shape that it makes has 5 faces. There are 3 rectangles and 2 triangles. So we know that the 3D shape that it makes has 3 rectangular faces and 2 triangular faces. We can now use these clues to work out what the 3D shape is. Can you name the 3D shape that has 3 rectangular faces and 2 triangular faces? Great work, it's a triangular prism. So when we can see the net and we want to know the 3D shape, we can identify the 2D shapes that form the net and use these clues to identify the net. If we can see the 3D shape and we want to work out what the net will be, we need to go the other way around. So we start by identifying what 2D shapes form the faces of the 3D shape. Let's take a look at this cube. It has 6 faces. Each of the 6 faces is a square, so we know that the net of a cube will be formed by 6 squares. Here are 6 squares, but will it form a cube? If we fold along the lines to form the edges and join up the square at each end, these squares would not form a solid shape. If you're not sure, draw the 6 squares on a piece of paper and fold it to see what shape it makes. If we look again at the cube, we can see that 4 of the squares need to be in line and the 2 remaining squares need to be on either side. By rearranging the 6 squares, we now have 4 squares in a line and the 2 remaining squares on opposite sides. This is the net of a cube. As long as there are 4 squares in a line and 2 squares on either side, it does not matter where the 2 remaining squares are. For example, the net could look like this, or even this. When we're working out the net of a 3D shape, we need to count how many faces there are and identify the shapes of the faces. To work out the position of the 2D shapes to form the net, we need to think about which faces are next to each other and which faces are opposite each other. Now it's your turn. For this question, you need to match the 3D shapes to their nets. One of the shapes doesn't have a matching net. Draw the net of that shape. Pause now while you answer the question. How did you get on? Shape 1 is a triangular prism and matches with net B. Shape 2 is a hexagonal prism and matches with net C. Shape 3 is a square-based pyramid and doesn't match with any of the nets. Shape 4 is a pentagonal prism and matches with net E. Shape 5 is a tetrahedron or a triangular-based pyramid and matches with net A. And shape 6 is an octahedron and matches with net D. So you needed to draw the net of shape 3, which is a square-based pyramid. A square-based pyramid has 5 faces, 1 square face and 4 triangular faces. So the net needs to have 1 square and 4 triangles, like this. Now it's time for your final challenge question. Shona says this must be the net of a cuboid because it has 4 rectangles and 2 squares, which is the same as the faces of a cuboid. Do you agree with Shona? Remember to explain your answer. Pause now while you answer the question. What did you decide? The answer is disagree. Shona is incorrect, and this is not the net of a cuboid. The net has the correct shapes to form the faces of the cuboid, but they are not all in the correct positions. The squares need to be on opposite sides of the rectangles so that they form opposite faces of the cuboid. This is an example of what the net of a cuboid could look like. Well done if you got that question right. I hope that this video has helped you to understand how to recognise the net of 3D shapes. If you're looking for any more maths videos just like this one, make sure you head to the Twinkl website to check them out. See you next time.